Okay, so the model we just covered, it's really not realistic. And what I want to claim is there another realistic model. This is due to I believe, a Belgian mathematician. And let me just go back over that. I'm not sure how to say his name, Pierre Francois Verjoost or something. I'm not sure. But anyway, he came up with this model over here. It's a more realistic model. All right. So where t represents time, y represents the population, and it's a function of time, by the way. All right. So the k is greater than 0. It's a growth model, and the a is something to do with the carrying capacity of it. Right. So what I want to do is I want to talk about the name of it. It's logistic differential equation, and it looks like this over here. And then the question is, they write this down over here. So what I want to do is I'm going to go to the whiteboard. Let me do that now. Let me get my eraser out. There's some doohickeys on this. My eraser's over here. And I want to see if I can figure this out. All right, so let's write this down. And I'm hoping it's going to be an easy thing to do. So dy dt is equal to k times y, and then 1 minus y over a. And again, this is new, so what we're going to do, I'm going to try to figure this out. To do that, a couple of things I could do. I'm going to just playing around with it. Dy dt. I'm going to say a here. I'm going to put ky, and this would be a minus y. That's not so bad. And then kind of looking at that, let's see what you could do there. And I guess what I could do is I could write this down now. And I would get, let's see, y, a minus y, dy. All right? So let me see if I did okay there. See what I did there. I got the dy part. I got the y, a minus y there. All right? What do I get on the right side? Let's write that down. You get k over a dt. All right, so I'm looking at this thing over here. I'm wondering, what could you do with that? And I guess what I could do is maybe partial fractions at this point. So let's write this down. I'm going to put this on the side for you. So I'm going to write, it's 1 over y, a minus y. I'm going to say this is equal, and I hate to use that letter a again, I'm not. I'm going to say I got y here, and I got a minus y here. What goes over here? Well, I'm not going to use a, I'll use b, and I'll use c. I'm going to clear the fraction, and what do you get? You get 1 equals b times a minus y. Then you can get c times y. Well, I'm going to pick an easy y value, and the y value I'm going to pick 0. And what would that give me? That would give me 1 equals, let's see, you'd get b. We're trying to figure out what b is, by the way. And then if y is 0, I just get times a. All right? So I think I know what b is. B is going to be 1 over a. Let me get my eraser out. I'm going to write that down now. So 1 over a. All right, let's keep moving. I'm going to pick another value. I'm going to say y is equal to a now. And what do you get there? Let's take a look at that. You get 1 here. And if y is equal to a, you can get c times a. Well, I know what c is now. It's 1 over a. So let me get that. I'm going to erase this over here. I'm going to put the 1 over a down. All right, I'm going to get rid of the baby work. And some people do that in their head, by the way. I'm often surprised by that, but they can. Okay, let me go back over here now, and I'm going to write it down for you. So I'm going to write down, it's 1 over a times 1 over y plus 1 over a minus y. And this is dy now. What do I give here? K over a dt. Let me put a little line over there. Well, I'm going to multiply both sides by a now. All right? I got some more manipulations, but it's going to be 1 over y. I'm going to write down minus now. And the reason just for me, by the way, you might not have to do that. And this would be y minus a dy. Makes it easy to integrate. That's why I'm doing it. And that's k dt. All right? What am I going to do now? I'm going to integrate both sides. And I'll put this down for you with the integration symbols. It looks relatively simple to do. I want to point out, y is population, so it's greater than 0. All right? So what do you get over here? Let's see. You get the natural log of y minus the natural log of y minus a equals k t plus some constant of integration. I'm looking at that, and really I'm in the same conundrum. I'm going to try to solve for y. And this over here is natural log of y over y minus a equals, well, this is going to be kt plus c. I'm going to start using some rules of logs I know about. So I'm going to say y over y minus a equals e to the kt plus c. This is e to the kt times e to the c. I'm going to call e to the c star. And that's going to be e to the kt now. And what do you get over here? We get y, and you get y minus a there. Again, I'm trying to solve for y, which looks, can it be done? I think so. Let's write this over here. I get y, and then I get, c star e to the kt times y minus a c star e to the kt. All right? I'm going to bring the y's on one side, and what do you get? You get y minus c star e to the kt y equals minus a c star e to the kt. All right? I think I'll multiply both sides by minus 1 now, and I'm going to factor the y out. So you get y, then you get c star e to the kt minus 1 equals a c star e to the kt. All right, let's keep moving. What do you get now? I can solve for y. And what do you get? I'll be careful here. You get a c star e to the kt. And on bottom you get c star e to the kt minus 1. And that just looks kind of bizarre to me. I'm not saying it's wrong, by the way. I'm saying it looks bizarre to me. And what I want to do is I'm going to divide the top and the bottom by, let's see, I'm going to say c star e to the kt. And what do you get? You get y equals, well, the top would just be a. And looking at the bottom, I would get 1, and then I get minus, right? And what would I get? I'd actually get 1 over c star e to the kt, right? So what I'm going to do is write that a little differently, make it a little bit neater. A, and I'm going to say 1 minus, well, I'm going to say 1 divided by c star is, I'm going to call it another, actually I'll just leave it as c star. You're going to get e to the minus kt, and that's going to be divided by c star. And now y is a function of time. What's that function going to be? A, which we call the carrying capacity of the population. What goes on bottom is 1 minus e to the minus kt divided by c star. All right? So we just solved that differential equation. Again, we have to take an example where we have concrete numbers, and we'll go through that. All right? Thank you.